So we created a table at this location. So if there exists any file in this folder, the queries will work. The Hive queries will work. But we are copying on an hourly basis the data here. So there will be a folder created, hence there is no direct file. There is a folder inside the Omniture folder, or a directory inside a folder, inside one more directory, hence we will not get any queries, will not work. Unless we say that this is our partition. So we yesterday itself we saw that if we give the query something like this, if I run this query, even though the data exists there, even though the data exists there, you are getting no results, because Hive does not understand any folder structure inside unless we say that it is a partition. So we have to say that it is a partition, just like this. We have to say alter table omniture logs and add if not exist partition. If not exist partition, we had created a table with partition as date time. So just specify that this is the partition we want to add. Just the timestamp. In this case, it's the folder name also is the same. And where the partition should be added, at which location, the same data with the path as the same path. So if I add this, you can give this command. You can give this command here itself. It says alter table was success. We added this partition. Now if I try to give the same, so now let's run this program. I mean, we just now did a select query. Select star from omniture, limit by 10. We are getting the result. Timestamp, IP address from where these are all the clicks data. As I said, omniture data is the clicks data. They clicked at this timestamp. The request came from this IP address. The request URL they clicked was this. User ID is something like this. This is a modified user ID. This is the modified. Sorry, this is the raw user ID. Later we'll be modifying that. City we have, country, state, and some partition. Date. So that's how you get the data now. We have our data stored in the table, but we cannot run this command, right? I mean, after every hour, you cannot run this command. You don't have to, I mean, we have to run this command on an hourly basis now. Otherwise, the next partition, one more folder will be created, but Hive won't know that. After again one more hour, one more folder will be created, but the Hive won't know anything about that unless you run this command. Unless you run this command. But you should not run this manually. Who will sit and manually run this command on an hourly basis? So you need to put this command in your Oozie framework. So in your Oozie coordination job, you put this. So what I will do is I will drop that partition as of now so that we can add it through Oozie. alter table, the same table, drop if exist partition. So I have dropped the table. If I run the now if I run this query once again, select the star, it says done. So because we have deleted the partition, we have altered the table and deleted the, because we want to do it through Oozie. So yesterday we discussed, one is the simple workflow. This was through simple workflow. Oozie. Simple Oozie workflow, I can say. Now in our second workflow is a coordination workflow, where as soon as the new data comes, first we'll run the Hive job. As soon as the new folder gets created, as soon as after an hour a new folder gets created, so we'll run the Hive job, which will add partition. Then we'll run our Spark job, which will prepare omnichannel data. We'll run one more Spark job after that, one after the other, which will prepare sales data. After that, we'll run one more Spark job, which will do sessionization. Something like this. I mean, sessionization is done in this omnichannel data itself. My mistake. Here itself sessionization is done. While preparing the omnichannel data, sessionization is done. Spark job 3, use that sessionization. We do, I mean, these two will be joined now. Join sales and sessionize the data. So we can get to know how many sales, all the sales details that happened during a session. So those are the jobs. Some top 10 top spenders job is also run on a daily basis. So this is optional. I mean, this is also one of the things. There is one more Spark job 4 we are running. So earlier it was done for a daily basis. It was not done on hourly basis. Just for demonstration purpose, we change it to hourly basis so that we can show that. I mean, for testing, it would be much easier. Otherwise, we had to wait for a day and then check. Spark 4 was top spenders on daily basis. So these were the jobs that are run. So since they are running these jobs in coordination, I mean to say, we are running all these jobs one after the other. So it could be also possible that after job 1 is run, after Hive job is run, it is also possible that you run 2 jobs in parallel, Spark job 1 and Spark job 2. You can run, that is also possible inside the coordination. It is not that it has to be sequentially run all these jobs one after the other. You can also fork. There is some Oozie fork command. Using that fork command, you can run 2 parallel jobs also. So that's what we mean by coordination. One after the other, or after completion of one job, you can run two more jobs in parallel. After the completion of those jobs, you can run one more job. Later, you can also run a job. So that's the meaning of coordination. So again, coordination job takes, as I said, every workflow takes two files. Coordination will take coordination workflow takes one more extra file. I mean, three files. As usual, one is dot properties file, but this properties file is the coordination properties file. One more is normal XML file, and sorry, there is a difference here. It has a properties file as usual, but we call it as, it's the same properties file where we specify all the properties. There is an XML on coordination XML, and one more is workflow XML. Because there will be multiple workflows, all these workflows will have an XML, and there is a coordination XML which coordinates all these jobs. This XML defines how one after the other each job has to run. How is the relation between the multiple jobs? Which job has to run first? After that, which job has to run? All those should be given here. As usual, the workflow will be, for individual jobs, there will be a workflow XML. And as usual, the properties will contain like the name node and all those stuff. So this will be a bit complex here. It is a bit complex because now it involves the times what input data set has to be taken on a timely basis. It cannot read all the data. It has to read a particular data. I mean, so whenever it is running for the current timestamp, it has to pick this folder. After that, after 1 hour, one more folder gets created. In that case, it has to pick that folder. It should not pick this folder. After again 1 more hour, one more folder gets created. At that time, the processing, the Hive or all that framework should pick the current folder. It should not pick the previous two folders. So all those things has to be configured in the Oozie coordination XML. It will be specified in the Oozie coordination. So if we go to the code drops, everything is there in the code drops. So in that we'll go to the local here. So you can see here the next one is submit coordinator.sh. I mean, I had this whole project was me and my team prepared this. Most of the coding was done by that person. So here these are the individual ones. You want to only run the prepare sales data. You want to only do the sessionization. You want to only do the daily top spenders. I mean, we tested it for individual jobs. All these jobs were tested individually because we want to make sure that whether this job works before running as a coordination workflow. We have to make sure that individual job works. So we tested it with the individual jobs. Then later we put it inside our coordination. So those things we have to do first. You should not go directly with the coordination because there might be some errors in between. The job might have been failing. First you need to test whether the job is working fine itself. So these are all for testing purpose that were used. These are all were the testing purpose. So we have already seen how to set up data. We have already seen how to ingest the data, and it should have been let's rename this to 0 because that's the order naming convention I am following. First you run this script, then you run this script, then 10 is the next script. So let's see how this coordinator job runs. So again there will be some Oozie command. It will have a Oozie command, just an Oozie command here, Oozie job config and the Oozie server, and we have to just say run. So here the properties file, if you see, let's see the properties file. As usual, yesterday also we specified the properties file where we had all the configuration information. So this is our, I think this was the one, right? Oozie coordinator properties. Right, Oozie coordinator properties. If I go to Oozie coordinator properties, so we have to now, one more thing we have is we have to specify the start date and we have to specify our end date because it is a continuously running job now. So all these jobs will be continuously running one after the other. Every 1 hour it will be running. So we need to have a start date when you want to start this coordination flow. And probably you want to run it for 1 year, or you want to run it for 1 month. You want to run it for 1 month, so you have to specify the end date also. So that's how it is. Start date and the end date. So this concurrency number of workflows to run in parallel as of now. How the execution should happen. We are having only one now, so we cannot fork and do the join. So first in first order is there. As usual, name node, job tracker. We have home directory, project directory, Hive site.xml, and we have coordination XML. I have named it as a schedule trigger ETL XML because we have to schedule one after the other. As I said, there are three files that are required. Coordination workflow has 3 files. We saw the properties files. Properties files has all the configuration information that will be accessible in the coordination.xml. Coordination XML says about in which order the jobs has to be scheduled, on which condition the jobs has to be scheduled. All those stuffs will be provided in the coordination.xml. I mean, the name is not coordination.xml. Some XML which is all about coordination. So we that's here. So let's see how it looks like. And also the actual workflow will be defined in this. actual workflow will be defined in this. So let's see how this coordination XML looks like. And this will be a bit complex here. It is in the project directory code Oozie. It will be in HDFS. So we can also check it here in our HDFS folder on our system also. So it is Oozie. In Oozie you should have scheduled trigger ETL. So here we give how often this job has to run. We are just saying monitor file arrival. The name of this coordinator job is this. How often it has to run? Everything is specified in terms of minutes. When we say frequency is equal to 60, it means 60 minutes. So every 1 hour, this job will be running. And what is the time zone we need to use for our running the job? Earlier, Asia, Calcutta, these job time zones were not supported. In earlier versions of Oozie, it had only, uh, I think GMT time zone was only, GTC or GMT. That time zone was only used. Now we can specify different time zones. With Oozie version 01, those things were not available, but now we can specify this. Again, we have our start time and we are having our end time. So these things we take it from the coordinator properties file. All the properties variables is accessible into our uh, coordinator XML. Then dataset is important. Now what is this dataset? The dataset XML specifies different data that must be made available for the jobs. Datasets always says, I mean, it defines how the data is on the HDFS. It defines how the data exists on the HDFS. Since we are copying the data in this form, since we are copying our data in this form, we have to specify to our workflows that the data will be available in this form. The data will be available in this form. This is just a template saying that data is available in HDFS in this uh, folder hierarchy or directory hierarchy. Base URL, we know what is base URL. Again, base URL is provided in our properties file. Project raw data raw. Project is nothing but home directory e-commerce marketing. The whole base URL. Then after base URL, we are having our omnichar. There we have year, month, day, hour. Year, month, day, hour. Now out of this we are just saying that this is how data is available. Now out of this data we have to specify some input data to our jobs. So that we specify through input events XML. Just be careful that this only defines how the data exists in the HDFS. This only defines. This does not say that this has to be the input to the jobs. The next XML element says that what has to be the input to the jobs. Now when I say coordinator current 0, let's say I'm starting the job at 8 o'clock. Let's say I'm starting the job at 8 o'clock. So this data input events, or what I can say here is, So we have user, Cloudera, then we have e-commerce, marketing, we have data. I think data is there, right? Then we have raw, then we have omnichannel. Then we have something 2017 11 09 07. Next folder will be 09 08 2017. So on, the folders will be created in the omnichannel folder. And this is what we are saying, that the data will exist in this form. Through this data sets, we are just saying that our data sets exist in that form for omnichannel as well as sales. Now what should be the taken as input now? Out of this existing data set, what will be the input data to our jobs? Something you just cannot say that this should be the input data to our job. We cannot say that some randomly, we cannot say some folder and that will be the input. So let's say we start our job at 7 o'clock. We start job at 7. Now what should be the input at this point? This folder should be the input. When we start the next job starts at next start job is at next job at is at 8 o'clock. So at 8 o'clock, this should be the input. This folder should be the input. Similarly, at 9 o'clock, next job at 9 o'clock. So at that time, this folder should be the input. This folder should be the input. And that is what that input events specify. So the data set just specifies the data, how the data exists. Then input events, it says that input name for omnichannel input is name. We are just giving some name. Data set, it says that the omnichannel, which is this. Our data in also has some name, so it refers to the data set in sales. Now current of zero means we are running this job at 7 o'clock. Current of zero means at 7. This path. Whatever is the data at this time. Current of zero specifies the path, what will be the data available at the zeroth instance, or the zeroth instance of data at 7 o'clock. I mean at 7, zeroth instance will be this. At 7 o'clock, zeroth instance will be this. Current of 1 instance will be this. Current of 2 instance will be this. So that's what they mean. At 7 o'clock, take the zeroth instance. So which is nothing but this folder. So that's what we are specifying. The input will be those things. Coordination current of zero will give the that path. So this is how we are specifying. All these things has to be specified, the data, how the data exists. I mean, there are a lot of things related to Oozie. I'm just giving a few of the things. Oozie still has a lot of things. I will share the document later, but that should be good. Now, now we are saying these are all the configuration information about the input data. Sorry, my mistake. I said that it specifies. I said that here ordering will be specified. Actually, ordering here data related stuff will be specified. Data sets, input data, all those things will be specified here. So here here it will be which job, the ordering of the job will be specified. Ordering and each job definition. So all the any input parameters, any variables that we use here will be accessible from here. Just like we are accessing the variables from the properties file in the coordination XML, in workflow XML, you can access the variables defined in this. You can use the variables defined in that. So we can use this. We want the date time also, right? We want the date time also, so that we want to create a new folder. What we do is, what we are trying to do here is, we have a raw data, omnichar, and we have 2017, 11, 09, and 7. So the Hive job, the first Hive job, it will add a partition. So no changes happens to the data. It will just say that this is the partition. Now what the Spark job will do is, Spark job will read this data. It will do some modification to the user ID, it prepares the omnichar data, and it puts this thing in a different path. So we had e-commerce marketing. So instead of e-commerce marketing, instead of raw, you will have omnichar. Some I don't remember now. Some other folder will be there, and the data will be copied here. Some prepare omnichar. Now we are copying the data from here. We are modifying. We are reading the data from here, processing this data and copying into somewhere else. But we also need to specify the date time. We also need to specify this timestamp. So whenever we are copying into some other folder, there also it has to be copied as a different folder with the same timestamp that we are getting from here. That we are getting from here. We are getting the timestamp for that, so that when we copy to one more folder, we also need the timestamp at this point. So this variable can be used in our workflow. These are all the different variables. Current date is one variable now. Date time is one variable. Omnichar raw path. Omnichar raw path is nothing but coordinator data in input omnichar. What is input omnichar? If you see the input omnichar, it is this. It says, so we need to represent these things with the variable so that we can use in our workflow definition. So this refers to omnichar raw path, refers to this data, which is nothing but which defines for which time interval what data path has to be taken. Time interval which data path has. So we have it for both. So we'll be using these things: current date time, date timestamp, omnichar raw path, and sales raw path. This will keep on changing for every hour. For every hour, this will be changing. This path will be changing, and it will be given to the actual workflow. So if I which is that actual workflow, we can see it on our properties file. This was that coordinator XML. This is our actual workflow. Prepare input data workflow. All those things we have to specify. So if I check this, prepare input data XML, prepare input data XML. So it defines in which order the job has to get started. So the job name is, the complete coordination workflow name is prepare data, and it will start from add Hive partition. So from that action it will start. So our action name, if you see, action name is add Hive. So it will start from here. It will start from here. So as soon as you put the data, we also have our job tracker. We also have our name node where the name node service is running. We also have where our Hive server is running. We also have our, which I think the name is a bit confusing. It should not have been read.hive.hql. It should have been partition.hql. More readability would have come. I think this was, you can rename this for saying Hive partition.hql. So let's see what does this Hive script looks like. It is the same script, same command that I gave. It is again in HDFS. If you go to Hive, so we can see read hive.xml. So we are doing the same thing. Alt table, this add if not exist partition date ts is nothing but this. So where did we get this from? Because that date we need, so we cannot hard code this. So we got it from our properties file. So if you see, this was the input parameter. Again, where did we get this from? This we got from our coordinator.xml. So this is why we need this date and time. This is why we need this date and time. It gets the nominal time. From that we need to get in this format, because our time or our folder is in this format. So that's the reason we are getting our timestamp in this format. So that will be passed on to here. That will be accessible in our workflow definition. So we have to give that as an input to our hive.hql script. So that can be provided to the HQL script to the parameter. Again, we need to define some variable for that, so that variable can be accessible in our, so this job just adds a partition. It doesn't do anything. The very first job just adds a partition that we saw now. So but it has to be done on an hourly basis, hence we have put it in the coordination workflow. Next after, if it is okay, if the job is okay, go to prepare omnichar data spark action. Go to this action. If there is an error, kill. If there is an error, kill it. Go to kill action. So if it is okay, it will go to the next action, which is nothing but prepare omnichar spark data. So this is our spark job. How to submit a Spark job on Oozie? This is how. Oozie Spark action. So again, it requires, what you can do is, there are some other things can be done. We know that all these things are common. Job tracker, name node, you can put it as a separate XML element. That is also possible. Separately as a one XML element, and that could be referenced in each of the action. That is also possible. Now we are running here. This is the Hive XML actually, and we are running on Yarn. Hence Yarn. We are running in the client mode. We have discussed what is Yarn cluster and the client mode. Then the name is prepare omnichannel data, and Anish is the person who does all the most of the development for my team. So prepare omnichannel data. So we will be running this program. We specify, right, which class has to be run, which main program has to be run. So that is there in our code. You can go through the code also. The code also exists there. So you can see prepare omnichannel data. It just reads this. This is that prepare omnichannel data. It just reads the data that was there in the Hive. So in the first job, we copied the data into Hive table. We added a partition. So we are reading that data from our Hive table. So there is a function that is being defined. We are just reading the data. You can also use Hive context dot table. Just create a Hive context and just say dot table and specify the table name. Omnichannel is our table name. We are specifying it through configuration here. So if I go to the config, all the configurations are specified here. Raw omnichannel Hive table is nothing but raw omnichannel. So this is what we'll be reading and doing the preparation. We want only on that current partition. We don't want all the data to be read. So that's the reason we are specifying the timestamp. So that only that folder will be read at that particular time. You should not read any other folder. So all this information comes to the job. So how we are specifying it through config again. Prepare omnichannel data. So it reads that from the configuration, it reads that timestamp it gets. So this is, as I said, this was our old data. For demo purpose, we have to modify the timestamp. If you remember, that's what it does. And sessionize is also done here. You can go through this. The sessionization is also done. It's a bit of a code you have to go through. So all the jobs we are specifying: prepare sales data, prepare omnichannel data, sessionization sales, then our daily talks. These are all different jobs which requires all these code, all these codes. So these all have main method. Prepare sales, prepare omnichannel data as a main method, prepare sales data as a main method, prepare map sessionization has a main method. So all these things has a main method, but they are all under the same jar file. So we have to just specify which program we want to run. Prepare omnichannel data. So it reads the data from the Hive table, modifies the timestamp and the user ID. And if you can see here, argument to our program is the timestamp. This date timestamp, from where did we got? We got it from our Oozie. So that is passed as an input to our program. We usually used to give through the command line arguments. So this also goes to the command line arguments. The date time goes there. The same date time is being used to filter the data so that you don't read all the data, you only read that folder's data on that job scheduling. So we need to also specify the jar file. 1 second. Yeah, we need to specify where the jar file exists. Where the jar file exists. We have copied our jar file, that e-commerce, whatever we did a make, compiled our project and created a jar file. That jar file is also there in our HDFS. And I think the Hive site may not, it is required so that we can. Oh, actually, yesterday I defined that. The question is how exactly Oozie architecture fits here. So so there is a blog, very good blog I said on, just search for Airawat Oozie blog. Most of the things what I learned is from her, from this blog. She has explained it in a very good fashion. Most of it has all the blocks, simple workflow where you can run HDFS. Scoop action also is there. How to copy. So in this case, we were copying the data from a external server using some shell script. If the data exists in MySQL database, you can use the Oozie job. Right, here it is the diagram I was just about to say here. So this is how the Oozie fits here. You have a Oozie client. Any job you specify on, just like we have Hive client and Hive server, just like we have MySQL client and MySQL server. Here also we have Oozie client and Oozie server. Oozie client is where you run the Oozie commands, where it will run the jobs. I mean, where the jobs will be given to this server. This server will take care of scheduling those jobs on the Hadoop cluster. So this is how the Oozie fits in the Hadoop. It may be out. It may be outside. It will be outside the Hadoop cluster. Just like Hive server 2, it may be running somewhere else on a separate system. So I hope Mohan that was clear. Right. So right. You will be running this from your client. 3 scheduling script. All those scripts will be running. You can have this client and this Oozie server on the same system also. It could be on the same edge node also. So this is your Hadoop cluster. Hadoop cluster. This is your Hadoop cluster. Let's say we have a edge node here. So in this edge node, you can have your Oozie server running. Client CLI client could also be there. Oozie CLI client. I mean console client. You can have the console client also here, and you can run your Oozie job here. Run your Oozie job. So Oozie server will take care of running these jobs on the cluster. Oozie server will take care. But you can also have this Oozie client. Suppose you are developing a web application. where from that web application you want to run your Oozie job. I mean, you want to give your customers or the team a web interface from where they can run a Oozie job. So now your Oozie job is your Oozie client is here. Oozie client is here, which will connect to this Oozie server. So that's the difference I'm trying to say here. So I hope, Mohan, that was clear. Just like Hue is the one. Hue is a web application. Hue may be running on some other server. Hue may be running on some other server. Hue is a web application from where you can submit a Oozie jobs. From here also you can submit. So Oozie client will be running in that case on that system. So that's how you run a second job. That's how you run a second job. I mean, as soon as this gets over, the first job gets over, this job will be running. Just we if you remember, we did a Spark submit. It's the same thing, but through a action. But through a action. Similarly, once prepare omnichar data is success, if it is okay, next next run the prepare sales data Spark action. Go to that action. If it is error, go to the kill action. So next we have a prepare sales data Spark. Again, it also requires a job tracker, name node, yarn, client name is the program name is or the class name is which we want to run prepare sales data. Complete path is this. The jar file is this. We can also specify this is how you specify because this the prepare sales data does not read from the Hive table. We know that for demonstration purpose, we have loaded the omnichar data to the Hive table. We have loaded the sales data to normal HDFS path. And we want to read it through the data source library. So we need to specify the package. It requires that CSV package. We are using the data source API to read that sales.csv. Hence packages. We can also specify executor memory, number of executor, just for how it should be given in the Spark options. Just to understand how the things work. You can give lot of options in the Spark options, packages, executor memory, number of executors, executor codes, all those stuffs. Then this program takes some input path, so we can give it here raw data source. So this again we got from our. We have to take only the required path, sales raw path. So that comes from our sales raw path, which is the current instance of our data, which is nothing but the current instance of our data. So where did I prepare omnichar data? Then we have prepare sales data. If it is okay, I mean, we have both the data ready now. So we have to merge or join these data and figure out how many sales those happens in particular sessions. So that is our map session sales. Again, run this as a one more Spark job. We can specify some executors driver here. I mean, this was we were using the cryo serializer. So this buffer size also was giving some out of memory. So we had to specify this. You sometimes you get, when we do cryo serialization, you get some out of memory issue. So hence this was Parquet compression codec, merge schema. These things even I am not much aware of, but I will let you know probably after I go through those things. So the idea here is how do you specify different configurations? Specify the date, the jar, and everything. If it is okay, next go to the daily top spenders. The daily top spenders also runs this fashion. So if it is good, go to the cleanup. So cleanup, if it is everything is okay, go to the cleanup. We are removing some underscore success from our path. Underscore success has been removed here. So the idea here is why it is being done is, so you cannot ingest the data unless the current data is processed. So this condition is used in the, this condition is being used in our ingest script. You are not able to ingest the data unless you have processed the current data. So that's the reason in cleanup we are deleting. If you see this, if you go to the ingest, so if we see here, check if a success file is present, which means previously loaded data has not been processed yet. I think it has to be. So that's what we are just checking here. So we don't want to copy the data unless the previous data is processed. So that's what that check is being made. Check whether the underscore success file exists. So how do we know that the current data is processed? The current data is processed if everything goes fine, it goes to cleanup, and in the cleanup action, we are just deleting that underscore success files. We're just deleting. So next time when you ingest the new data, so first it will check whether this file, if it exists means these processes has been not completed. So if it is error, it goes to the kill, so it will just kill the. So this is how you run your Oozie job. So we have to make slight changes here, so that what I will do here is, so we have to run our Oozie coordinator job. So we have to make some changes because the start date is something different. So we have to submit this. We have to just run this script. So but we need to change some things in the properties. The properties, it's already open. So the start time is 2017, month is 11, time is what is the time here. This time we have to check, because the I mean, we want to start it now. It will take the previous folder also. It is 8th of November. We'll say 6:50. As of now, it is 6:48. We will start at 6:50, and this will say 11:31 for 1 month. So this has to be copied to the Oozie folder, because this properties file is fine. It should be in the local itself. So we have to just run this program now. UTC format. Invalid coordinate replication. Its parameter end. What happened there? Nothing is wrong, right? What is the error it is giving? Invalid coordinator application attributes. Parameter end is equal to 2013 17 11 31 must be the date in UTC format. Year, month, day are the same format, right? Year, month is this, date is this, T is here. Next we have 08 R. Minute is this. Could not parse this. How it is not able to parse this? Oh, okay. Okay. Thank you. Thanks, Gopi. November has 30 days. So you can submit the job here. You can check on the Oozie how the job is running. We go to the Hue. In Hue, we can have dashboard. Oozie has its own. If you click on this, Oozie has its own web UI where you can see the jobs running. But Hue gives us a better view of how the things are. You can say coordinators, because we are running the coordinator job. So coordinator job is running. So let's check how it is. So we'll get all the. There is slight error here. Actually, it should not give all these things. It is giving the next job also, it is still the next job also are waiting here. So I need to check why is that, but this is the one. Actions you can see it's already 8:52, right? Why it is waiting? These are the other jobs. Okay, it is waiting for 06. This folder does not exist. This data does not. We have scheduled the job. This job is waiting for this folder to exist, but we don't have that data. We don't have this data. 086 data does not exist, so hence it is not starting unless that folder exists, unless the data exists, because that's how we have specified in our coordinator XML. So unless this data exists, so it is, so this we have run it at 6, so it is looking for the data 6th hour of the day. At 6 o'clock, whatever is the data, it is looking for that, but we don't have such data. So in our HDFS, we have some other data. We have yesterday's 07's data. Now I cannot ingest it because while ingesting it, it checks whether the success exists in the previous folders. So I have to just delete these folders. What I will do is I will, so you can delete from Hive also. Just go to the Hive. There will be something called as a file browser. You can go to the file browser also. From there also you can delete. From here also you can go there. You can go to e-commerce, select this code, not code, we don't want to delete that. Select data and just say action, move this, move to trash, we can say. Move to trash or delete forever. You can delete from Hive. Hive is just a good web UI tool where you can do all those stuff. I have deleted this data. Let me ingest the data once again. So it may time out. Something happened. Let me ingest this data. My mistake. data drops and online data drops. Okay, 0818. Oh, it's 6 p.m. So I need to specify the start time as this. Let somewhere around this has to be the start time. I didn't see that PM. It should be that. There's something messes here. I don't know what messes here. What was the date? 18, right? Not 18. Right, 18. Date is same. Let's start it. So it's already 17. 6:59 it is. So I need to kill the. We can kill the job. This job also. Let's say kill it. The job will be killed. As of now, nothing exists. My mistake. What I will do is I will remove because it has already crossed 7 o'clock now. 7 p.m. here. So let me do is I'll ingest it once again so that we get a correct time. Just delete this data once again. So that we can have a good timings. The data does not exist. I will just ingest once again. So that we get a 19 as the timestamp. Last time it was 18. So we got this folder. I think the setup is already done, I suppose. The table should have been created. It was already created. No need of running that command once again. Even if you run it, it will delete and create it once again. So we have all our tables: processed, raw, and warehouse. All the tables exist here. So a database, inside the database there should be omniture. So if I give this command, it should not work. So anyway, it should not work. If I add the partition, it should work. So next we'll start our coordinator job. So in the properties, we have to specify. Let's start at 19. 19 means 7. 19 5. At 5 minutes. 5 past 7 will start. Submit the coordinator job. If you go and check here, you should be having the coordinator job done. The earlier one I have killed it. Let's check the current one. So if you see, this is running. Earlier it was always in the waiting. This time it is running because that folder is available. The next job will run whenever this folder becomes available. 20th. Next instance of this coordinator job will run at 20th, as soon as it's 8 o'clock, and that folder gets created. This is running because the folder with 19 is been created. That's the reason it is running. So you can check on this. So you can see that Hive action is successful. It has added a partition. Since it has added a partition, this query should work. This query should work here. So you can see that this query is working because the partition has been added. So the first job is over. As soon as add partition is over, we are running prepare omniture data star. So once this gets finished, the next job will be running. So it will take some time because I'm running on a single system. Any details about whether it has failed, all the things you can debug in the logs. The logs will give you all the debug information, so you can debug those stuffs. Once this gets finished, you can click on the next job. What is happening? Task. Go to the task. You can go there. Some containers has been allocated. Everything is running on ER. So you can click on the logs here. So you can debug any error you are getting. Sometimes it may fail because my server is not so new server, it's an old server. Sometimes the hard disk doesn't work for my servers. Some things are going on. If it was in AWS, it would have been much faster. So any errors you want to see, you can check it here. Let's go back to our format workflow. So the prepare it's still running. Usually it should finish. It's only because of my system. It's taking time. We can also check things on the web browser itself is not working. Anyway, we can see that earlier it was 66%, now it has 75. It's been working there. So finally what I can say here is finally our data will be ready for to give such queries. You can give such queries. Top 10 or where is that? Finally our data will be ready to give these queries. You can give all these queries from your Spark shell. Open the Spark shell, Spark-shell, or some web tool. I mean, here I don't have a web UI tool, BI tool. Spark shell can be treated as a BI tool. From the Spark shell, you can give all these queries. Sessions which resulted in a sales, sessions which did not resulted in a sales, total invoices per session, distinct products sold in a session, cities. So to make available, to give such query, we have to make our data available in that fashion. So that was the ETL job that we did here. Finally, from the BI tool, you may be giving such type of queries. Such type of queries. So I hope you got the complete understanding of how a Spark job fits into the Hadoop ecosystem, how an end-to-end pipeline is developed here. I would recommend to run this program once on your own cluster. If you have a Cloudera cluster, right? but it requires a lot of CPU core and RAM. Unless you have that, you cannot do that. I would suggest to do such a thing so that you get a hands-on on how end-to-end pipeline works. If you have any problem, you can always contact me with these things also. Let me check that once again. Finally, you should give these queries. I wanted to show how to give that queries also, but the job is not yet finished. So the web browser has stuck. It got closed. Let's check once again. So earlier, the other next hour sessions has timed out, so that I need to check. So you can see that Hive partition was done. Prepare omnichar data is also successful. Prepare sales data was also successful. Then the next job is running. One after the other, these jobs will be running. Once everything completes, again after 1 hour, the whole jobs will be running. Again after next hour, again the things will be running for the next folder that gets created. The same thing keep on happening every hour here. But every hour there is some problem in the code. Every hour it is timing out on Oozie. I don't know why it is timing out. So let it happen. So this prepare omnichar data saves the data somewhere else. If I go to the file browser is on the right hand side on the hue. E-commerce marketing data raw omnichar. So all the other folders gets created. User Hive. Go to the Hive. It becomes slow. I will go to the warehouse. Sorry, it's because of its slow. I'm not able to browse it properly. Go to this path. So we have processed data. So you can see that in the processed DB, these folders got created because prepare omnichar data has did this. So it read the data from the external table, processed it, and it has saved it in the Hive warehouse. We have saved it in the Hive warehouse as a new table. So it will keep on getting created for every 1 hour, one more folder gets created. The process data is being copied to Hive data. Similarly, you should also see it's a bit slow. You can also see that these tables and databases we had already created. This process database was already created during the first setup. In that case we have, and we are saving the sales data as a Parquet file. The data is being saved as a Parquet file here. So after sessionization, again let's see whether it's working. No, sessionization is still working. Once we have all the processes up and running, then we can run our Spark shell and give the queries. So I can also start Spark shell here. Meanwhile, let it complete. So this you can imagine like a business intelligence tool from where you can give your queries, whatever queries I have specified there. So you can give all these queries here. These things I have to copy. Can I make this available? This is my different system, that is my different system. So I want this to be on my Cloudera. So I'm just sending it through mail. Hive context has been created. I think this is warehouse sessionized map might not have been created yet, but it's still working there. So you have to just give all these commands, just for check whether all the things are working here. The table might not have been created. We didn't see this. Only once that job gets over, this folder gets created. I think the job is still going on. Yeah, a map sessionization is over. Sessionization is over. Next we are running our daily top spenders. That is also finished. So our query should work now. So you can see that we are able to see the result. Session ID has been added. So these things were not there earlier. The session ID was not there. Session start time, session end time. Along with the user clicks and sessionization, we also are getting our invoices. At this particular sessions, nothing got sold. There was no this session. Again in this session, nothing gets sold. So all those things we are getting here. So we can also give other queries. We can specify the top spenders. So we can see the user ID with the top spenders. At a particular timestamp. Similarly, we can give other queries also. Sessions which resulted in a sale. Give me all the sessions which resulted in a sale. Value filter is not a member of unit. Where did unit came here? Okay, my mistake. So I have to create that session map, right? Val session mapped. You just copy till here. Don't use the show. That's the reason it was giving the error. Val session mapped is this. On that session mapped, just say filter and give all the which resulted in all the sessions that resulted in a purchase. So these are all the sessions that resulted in a purchase. This was a session. This was the invoice. What purchase were done? Six quantities of this stocks was purchased, and that in that session ID. Similarly, we can specify other things as well. All these you can specify. Sessions which did not result in a sale, just invoice is null. We can specify. Total invoices per session. Distinct products sold in a session. All these things you can specify now, because our our data is ready for such query. We did a ETL on such stuffs and we were able to achieve these stuffs. In the queue, everything else works fine. Again, the whole thing will work once again after 1 hour. But that there is a problem. Actually, it should not. I don't know what is the error. In the first go itself, it was in the waiting state for the next star. This was for the next star. This was for the next star. Again, next star. Keep on. So these have timed out. It should not start at the start itself all the next hour's jobs, but it has started, but it has timed out. Otherwise, it should, after 1 hour, this should come. Again, after next 2 hours, this should come. After 3 hours, this should come. But initially itself, it is coming all the things and it is timing out because the data was not available. There is a small bug. I need to fix that. Otherwise, this is how things happen. This job is over now. After next hour, this job will be done. After 2 hours, this job will be done. Again, in that job or in that workflow coordinator job, all the workflow will be running. So I hope you got an idea of how the end-to-end pipeline works. I mean, I did not explain it everything in detail, but I hope I was able to convey how an end-to-end pipeline works. So that ends the Spark SQL. Tomorrow, I mean, who are interested in Spark streaming, we will start with the Spark streaming tomorrow. We'll include uh, Kafka there, Kafka with Spark streaming. So let's wind up the session here and let's continue tomorrow, same time. So just before concluding, I just wanted to show that once everything the processes, everything will be kept here. Omnichar data, this is the process data. Sessionization data is here. In the warehouse database, we are creating a table, sessionized map, daily spenders, daily top spenders, usage logs. So these things are, I mean, those jobs that we ran, those jobs created these folders. These jobs created these folders. Daily top spenders for 19, daily top spenders for some other data, daily top spenders for next day. Keep on, it will happen. It will keep on happening. So that whenever you give a query, you don't have to fetch all the data. You can fetch only the current folders data. Current folders data. So I hope the things got clear here. So let's wind up the session here, and tomorrow we will start with the Spark streaming. So directly we'll start with Spark streaming and Kafka. Thanks everybody. Good night and have a nice day.